Good evening. So it's a pleasure to be here. My name is Marky Muryawan. So I work in UN Statistics Divisions. I'm responsible for international trade statistics, but at the same time also I'm coordinating to work on AIS. This morning I will make presentations on AIS, what is AIS, and also some of the use cases that can be your inspirations. Let me share my screen. So let's start to learn what is AIS. So AIS stands for Automatic Identification Systems, which is a tracking system for ships originally developed for collisions avoidance. So this illustration is basically how the data flow comes from the ships, which are being transmitted through the AIS transceiver, right? And it gets captured by a certain ground stations or satellite network, and then it will be aggregated into a useful data and informations by Maritime Data Aggregator, and at the end, the AIS data users like us, we can start analyzing the data. So basically, what we need to understand that there are certain AIS messages, which is the static informations that do not change often and usually are input by the seafarers. So that contains, like for example, a call sign of the ships, right? The dimensions, ship's name, and so on. The dynamic information. So this is something that are very important for our analysis, because these sensors would capture the ship's movement, including the GPS positions, speed over ground, course over ground, and so on. And another informations that can be captured is what we call the voyage related. So it also include information such as destinations, estimated time of arrival, draft, and so on. So all of these information are captured by these AIS receivers, and they are being aggregated as I described earlier. So what are the coverage of the AIS datasets? Luckily, we have a very good coverage globally, right? So this is also one of the big datasets that are interesting to use because of its accessibility. So it's basically it contains all of the tracking movement of the vessels of the 300 gross ton, right? And also the cargo ships of 500 gross ton that not engage in the international voyage, and all of the passenger ships, right? Irrespective the size for safety reason. So AIS is basically regulations in the maritime transport, right? This basically is part of the SOLAS, which is a conventions for safety of life at sea that are managed by IMO, which is International Maritime Organizations, which is also part of the UN system. So these ships, that around 100,000 ships currently on the sea and also in the inland waterway. So they transmit the AIS messages, that what I mentioned earlier, remember, static, dynamic, and voyage related. A few seconds to few minutes, depending on the situations, whether they are harboring or whether they are moving. So in general, in the global data set, so we have around 300 billion AIS messages per year, right? So this is what we have in our UN global platform. It covers globally, right? So we have all ships that are compulsory to have AIS messages, right? And what we have is also the as of 2005. The reason is that the SOLAS regulations, what I mentioned earlier, so it was decided in 2004. So let's focus. Okay, so we know that AIS is a ship's tracking movement. So how can we get it? So AIS is basically a radio signals, right? So it can be also captured by individuals, right? If they have a proper equipment to receive this. So I also indicated that we have the satellite networks that capture mostly the ships moving on the open seas, but we also have a terrestrial receivers, right, which is around 40 sea miles that can also capture the movement of the ships, usually when they are coming in and out of ports. Luckily for us, there are several data providers, right? Whether this is a commercial a community or also the port authority or coast guards. Right? So the coast guard in countries, they also capture these AIS signals, and they also may make the data available. I think how you want to choose the data provider is really depend on the on the needs, right? So if you would like to analyze a global ships movement, right? So it's maybe better to go for a commercial solution that cover a global coverage. Whereas if you want to focus on a certain ports in your country, maybe you can go for the data that captured by port authority or coast guards. So these AIS signals are basically encoded, right? And the decoding and the cleaning of AIS messages are usually undertaken by data aggregator. So this is also one of the reasons some of us use the data made available by commercial entities, because they also somehow validate and clean the data sets. And and of course, this data aggregator, they may exchange the data among themselves. So some of the satellite provider, they may lack some informations in the terrestrial ground, or the other way around. The data provider that focus on the terrestrial receivers, they may don't have access to the ships on the open seas. So usually this data aggregator, they exchange the data among themselves and then provide the data services to us. So far, I have explained the good part of AIS, right? A global coverage, more or less a good quality of the data, accessibility, and so on. The problem is that the AIS messages can be lost, it can be also corrupted, right? So this will lead to some strange locations. For example, some ships may be detected somewhere in a mid-continent instead of the sea. One of the most important consideration is the AIS transponder can be turned off, right? Because this is just a device on the ships that can be turned off by, someone on the ship. One of the also the understanding on the limitation is that AIS is not intended for analysis, right? But in fact, is intended for to avoid collisions on the sea. It also means that some of the informations may be not available. For example, if I want to keep track on the cargo on the ships, right? So we cannot have it in AIS messages because it's not designed for it. The land-based transceiver has limited coverage, right? So it has to be added by also the data from the satellite receiver. But again, the data aggregator will complete the coverage for us. There is some also update or delay or human error in updating the static messages, right? So this will also lead to low quality when we analyze the data compared to the dynamic data sets that are captured in sensors. So more or less, I gave you a brief overview on AIS. So maybe now I can give you some examples, right? What can we do with these data sets? So if you look at the use cases, right, the first use cases is what can we do for SDGs, right? So in SDGs there is no specific indicators on maritime transport, but of course maritime transport and AIS are important for others. One of the example is, for example, to indicate a target 14.1 in reducing marine pollutions, right? So AIS can detect the maritime emissions, taking into account the speed, right, the weather, also the fuel consumption on the specific ships and so on. So this can also indicate a certain kind like a maritime emissions coming from the ship. So we have some example later. Another example is that 14.7, increasing the economic benefit for small islands developing state. So we know that the small island countries, they depend on maritime transport, right? So by tracking the AIS, the ship movement through AIS, we can have a better information coming out for these islands, especially that they may have not enough resources to compile the data timely and with a better accuracies. Another example is 17.7, which is promoting public, private, and civil society partnerships. So what we have been doing in our global working group on AIS Task Team, right? So basically, we collaborate with academia, with private entities, statistical offices, port authorities, and promoting the use of AIS. So this is just an example of some of the SDGs targets and indicators that we can take advantage by looking at AIS datasets. But something that is more important is I give you some more down-to-earth examples on the use of AIS in datasets by various organizations. So first is the faster economic indicators from Office for National Statistics in UK. So they would like to have an indicators, right, so that they can act quickly, right, in response to economic changes. So so you know that the UK also they are an island, right? So meaning that having information through AIS more or less will capture the activities. Trade activities coming in and out of UK. So far they have developed certain indicators, right? The first is time in port, right? So it's basically aggregated time in seconds spent by ships in UK. So they also have a port traffic, right? So the number of ships entering the port, right? With intentions to load and unload. And then they also want to capture the number of visits, right? For example, they want to figure it out a certain trade route. So how they do it? So basically they, because this is a special data set, right? So they define a port area using a bounding box, and then we have to filter some noises, right? So because not all messages coming from the ships, right? So we have from buoys and water levels and so on. And we also, some ships are not considered transporting goods, right? So for example, some ships just passing by, right? Or passenger ships, right? So all of this has to be filtered. And then there's certain activities on data cleaning and preparation. So it's basically trying to prepare the data for better analysis. So something that is important to underline is this moving ships filter, right? So meaning that if the ships are just moving towards this bounding box, right? So it shouldn't be counted, right? So basically they are only passing through or transiting. But nevertheless, AIS information may capture this inside the bounding box. So this is kind of like an example of bounding box, right? So define the bounding box, and the ships will coming in and out of this bounding box. And then of course we need to filter and make sure that this is the ships that make economic activities. Another example is the further than just counting ships in the ports, right? So we want also to count the trade. So it's basically the work of IMF colleagues is basically on top of the work then that already done by UK ONS. So in addition to port visit or port calls, right? So they also want to indicate how much cargo are loaded or unloaded, right? And then so once they have this, they can compare it with official statistics, because we know that customs also capture informations on the trade volume. So how they do it? So it's basically they will measure the draft, which is basically the length between the water level and the water level and the bottom of the ships, right? So when the ships is loaded with cargo, right? So it will be the drought will be higher compared when the ship's empty. So by tracking this changing in draft, so they are able to estimate. So one of the use cases in Malta. So so basically they try to they try to measure the trade volume through AIS by indicating whether or not the ships have event of loading and unloading, and then if they do, they will estimate the trade volume by looking at the change in draft. So this is basic methodology, and so this is basically the some of the result, right? So the the red one is basically the official statistics, right? And the blue one is the AIS. So what they can see is basically AIS is even though the level is not exactly the same, but they follow the same trends, right? So it also means that the quality of both statistics are quite good. Another use cases is a little bit different. So this is the work of Statistics Netherlands. So they look at the cruise tourism in one of the Caribbean island, Bonaire. So the reasoning behind it is that the cruise tourism in that island is very important, right? So for example, in 2019, there's 500,000 passengers coming. So how they're doing it? Exactly similar thing. So they set a port area bounding box, right? They calculate port calls only for the cruise instead of the cargo. Remember, before we are calculating a cargo, and then they try to benchmark the data with administrative records. So they do have some records on arrival and departure by port authority, right? They also have some records captured in the system of the customs. I think one of the challenges is that even though we can track when the cruise ships visit the islands, right? But it is still hard to evaluate if the passengers visiting the islands, right? So we know that the ships dock, but we don't know exactly how many passengers are in the island, right? So the AIS wouldn't go that far. So this is also something that we can explore further if we want to combine with the mobile phone data, for example, because some of these passengers may bring the mobile phone and when they go inland. So this is something that we can do earlier. Another use case is the fisheries. So this is one of the case work in the EU Joint Research Center. So they are trying to identify a fishing area I think in North Sea. So the goal is they want to look at the more into conservation and protections, right? So they would like to see if there is a collision with whales and illegal fishings and also transshipments. So the methodologies is a little bit more complex because they don't really have a bounding box, right? Compared to earlier use cases, but they have to focus on the fishing fleets, right? And then they also need to combine with other data sources. Like in this case, that you have to combine it with the EU fleet registers, monitoring system, and so on. So this is just an example. So on the left side is the AIS, right? So AIS managed to plot some activities of fisheries in the North Sea. Whereas on the right side, this is the logbook that the fisheries basically submit to the authorities. So you can see that even though it's not exactly the same, but you can see that more or less they are very much correlated, especially the different color coding, that a little bit darker will be similar in here. Finally, this is the last one. So I already mentioned that the maritime emission is one of the high topic, right, in many of the international agenda. So we had AIS hackathon, and one of the winner of AIS hackathon is basically working on to calculate the global emissions. So they use the various methodology, including machine learning. So they mesh up the AIS locations and then the EU TETIS MRV vessel emissions, and then they put them together and then they put it in the model. So this is the result, right? So they built the dashboard, and then you can see that certain area they have more emissions compared to others, right? So basically, when they are passing through the ports. In canals west, for example, and then of course in the China is quite high in emissions in this calculation. So this is something that we can have from looking at the maritime emissions coming out from the ships. The last one is the curriculum. So in addition to look at the use cases, we also work hard on make sure that we have a good curriculum. So we have engaged several sessions on the curriculum design, and basically we found out there are two kind of curriculum. First one is the core curriculums. That is basically what kind of the basic skill that you needed to manage a big data. So it's a coding, right? The methodology, the project management, leaderships, visualization. So all of these are cross-cutting. It's not exactly for AIS. It can be also for use from others. Whereas for AIS itself, so we have identified certain courses, right, from the beginning, right, to explain what are AIS, and then acquisition of the data, the cleaning of the data, and then at the end is the integrations and analysis itself. So that a student, for example, at the end, they were able to calculate the maritime emissions using AIS data, right? So this is talking about this. But of course, we have a lot of courses that they have to go through. But nevertheless, we already have something, and we are still working to finalize and to develop these courses. That's it. Thank you very much for your attention.